Okay. Sigma is known, and it is normal, or n is greater than or equal to 30. So again, this is a z-score test, which means that sigma, the population standard deviation, is known. On the other one, it's going to be, which is going to be 7.3, is going to be a t-test. And on a t-test, you use the t-sheet, you write with the chart, and that's when you don't know the population standard deviation. So just like confidence intervals, the only difference is knowing the population standard deviation or not knowing the population standard deviation. This is in the problem. It'll tell you. Okay, next. You're going to write the null and alternative hypothesis. On the remember side, I'm going to write either one could be the claim. Also, H sub O and H sub A is what we're talking about right now. Okay. Next, you're going to find the level of significance and the rejection region. Over here, I'm going to write draw a picture. No. But we will right now. So before we continue on steps, I'd like to just go to example 1 and do these first 3 steps with you, so you get what I'm talking about. All right, remember how I told you that hypothesis testing is situational? It is only story problems. This is literally stuff that you would do on a job. Employees at a construction and mining company claim that the mean salary of the company's mechanical engineers is less than one of their competitors, which is $68,000. A random sample of 20, I'm going to start writing down stuff I know. N is 20. Of the company's mechanical engineers has a mean salary of $66,900. So that says X bar, when they did their test, was $66,900. Assume that the population standard deviation, that's sigma, is $5,500, and it's normal. Okay, so I'm going to just put a little step 1 next to this word population standard deviation. That just tells me I'm doing a z-test. Step 2 is to write the null and alternative hypothesis. H sub O, H sub A. What is their claim? It says their mean, so we're doing a mu, right? Mu is less than 68,000. Okay, so it's less, which one should I put less than on? The H sub O or H sub A? H sub A less than 68,000. And that's because there's no equal sign to it. I'm also going to write the word claim after it. And over here, I'm going to write greater than or equal to 68,000. Okay, step 3. I'm going to draw a picture. Left-tailed, right-tailed, two-tailed. Do you remember how to tell?
Right-tailed?
Nope. It is left-tailed. So if you don't know, you can always look at the notes from yesterday, but it is always the alternative. So the alternative is the one where that has the tail. So this is left-tailed right here. So I'm gonna draw a little picture, left-tailed. The null is over here, the alternative is over there. And when I talk about rejection regions, I mean we're looking right here. This is the level of significance. So the level of significance of this problem, I'm gonna write it on top. Level of significance is alpha equals 0.05. Alpha is the probability of making a type 1 error. So that means that this area over here is 0.05. So when I say we need to find the rejection region, I mean I need to know what z-score is on the edge of this region here. So if there's 0.05% area over there, how do I find out what this boundary is, what that z-score is that separates 5% from the rest? Yeah, let's look at the table. We're looking at the z table. Look it up. Why don't you stand up real quick? Stand fully up. Wave your hands above your head. And go. Go. Ah! Go on.
Do it. Say it out.
Oh.
What's
Okay.
Level of significance is type 1 error.
Level of significance, yes, I believe is type 1. Let me make sure though.
What is that? Okay.
Alpha is, yes, a type 1 error.
What?
Okay, so here we go. Where am I looking at 0.05? In the middle of the table. Everybody's looking at 0.05 in the middle of the table. I got right between negative 1.64 and 1.65. So this is negative 1.645. That is my rejection region. So here's the deal. If my test statistic, when I do my test, if my z-score falls in the rejection region, I'm going to reject the null. And if it falls over here on the right, I'm going to accept the null. So if it falls on the null side, I accept the null. And if it falls on the rejection region side, I reject the null. Yes?
What if it's right on that line?
It won't be. Because it's a normal distribution. That's like me saying, are you exactly 6 feet tall? And you say, sure I am. And I say, let's measure you. And then you're actually 6 foot 0.01. Like you're a little bit, you know what I mean? Like it's impossible that you're exactly. If we go to the hundredths or thousandths or whatever you want to call it, then it's going to be on one side or the other. Okay, so x minus mu over sigma, except for it's x minus mu divided by sigma divided by the square root of n, central limit theorem. So you're right. Right? Next up, find the test statistic. This is what we're comparing to our rejection region. This is z equals x bar minus mu over sigma divided by the square root of n. Okay, this is